Hello, hi everyone. Welcome to the Student Brand. This is your Shiva sir. Today topic is light reflection and diffraction chapter CBSE Grade 10 Physics. Light reflection and diffraction chapter. Light reflection and refraction. So hello, hi everyone. Welcome to the Student Brand. So very important topic. Okay, so light reflection and diffraction. CBSE Grade 10 Physics. Today we are going to discuss about this topic. Now you can see here, I'm taking the plane mirror. So plane mirror I'm considering. Okay, so plane mirror. This is a plane mirror. One side is coated, another side is reflecting surface. One side is coated, another side is reflecting surface. Okay, so if the light is incidenting on the surface, if the light ray is incidenting on the surface, so this is the incident ray and reflected ray. So the line which is perpendicular to the plane surface is called normal line. So incident ray, reflected ray, normal line. Incident ray, reflected ray, normal line. Okay. So the light ray which is incidenting on the surface is called incident ray. Incident ray. The light ray which is reflecting back is called reflected ray. Reflected ray. The light ray which is perpendicular to the surface is called normal line. Is called normal line. Okay. So the angle between incident ray and normal line is called angle of incidence. Angle between reflected and normal line is called angle of reflection, and this is the undeviated line. Okay, so undeviated line, right? So here the angle between reflected ray and undeviated line is called angle of deviation. Angle of deviation. Coming to loss of reflection. Coming to loss of reflection. Loss of reflection or loss of reflection. Loss of reflection. Loss of reflection. First one is incident ray, reflected ray, normal line lies in the same plane. Incident ray, reflected ray, normal line. Okay. So incident ray, reflected ray, normal line lies in the same plane. Second point is angle of incident is equal to angle of reflection. Angle of incident is equal to angle of reflection. So loss of reflection, first one incident ray, reflected ray, normal line. Incident ray, reflected ray, normal line lies in the same plane. Angle of incident is equal to angle of reflection. Angle of incident is equal to angle of reflection. So normal means, okay, the line which is perpendicular to the plane surface. So here I did dotted lines. Okay, so I drew the dotted lines. These dotted lines actually, those are imaginary lines. Those lines are not existed. Okay, so just for understanding of reflection of light, so we did that one. Okay, so that is a normal line which is perpendicular to the plane surface. Coming to the angle of deviation. So angle of incidence plus angle of reflection plus angle of deviation equal to 180 degrees, because linear angle is 180 degrees. Linear angle is 180 degrees. I hope it is very clear. Understood? Now here you can see, angle of incident plus angle of reflection plus angle of deviation equal to 180 degrees. From loss of reflection, we know that angle of incidence plus angle of deviation equal to 180 degrees. So angle of deviation equal to 180 minus 2 angle of incidence. Angle of deviation equal to 180 minus 2 angle of incidence. Now we can also write angle of deviation, so 180 minus 2 angle of reflection, because so here from loss of reflection, angle of incident is equal to angle of reflection. Angle of incident is equal to angle of reflection. By that, we can write angle of deviation equal to 180 minus 2 angle of incident. Angle of deviation equal to 180 minus 2 angle of reflection. I hope it is very clear about it. So, yeah, reflection of light is nothing but the bouncing back of the light from the reflecting surface. The bouncing back of the light from the reflecting surface is called reflection of light. The bouncing back of the light from the reflecting surface is called reflection of light. The bouncing back of the light from the reflecting surface is called reflection of light. Okay. So, incident ray, reflected ray, normal line. Incident ray, reflected ray, normal line lies in the same plane. Angle of incident is equal to angle of reflection. Angle of incident is equal to angle of reflection. Okay. So this is about laws of reflection. Coming to the linear angle is 180 degrees. Linear angle is 180 degrees. So angle of incident plus angle of reflection plus angle of deviation equal to 180 degrees. Angle of incident plus angle of incident plus angle of deviation equal to 180 degrees. Angle of deviation equal to 180 minus 2 angle of incidence. 2 angle of incidence. I hope it is very clear. Now angle of deviation equal to 180 minus 2 angle of reflection also. We can take like this also. So two formulas we consider, right? Now, so we will go to the next one, that is about regular reflection and irregular reflection. Regular reflection and irregular reflection. Regular reflection and irregular reflection. Actually, based on this one, we have to do problems also. There, theory questions also there. We need to do it. So now we will discuss about regular reflection and irregular reflection. Regular reflection takes place on a smooth surface. Irregular reflection takes place on rough surface. Regular reflection takes place on smooth surface. Irregular reflection takes place on rough surface. I am taking here the regular reflection. Regular reflection. Okay, so here if you are taking, so this is a plane mirror. Incident light rays are parallel, then reflected light rays are also parallel to each other. So incident light rays are parallel, then reflected light rays are also parallel to each other. So this type of reflection is called regular reflection. So here I am taking, these are the incident light rays. I am taking here, these are the incident light rays. Reflected light rays are also parallel to each other. Okay. So this type of reflection is called regular reflection. So reflected light rays are also parallel to each other. So here you need to understand one thing. Regular reflection takes place on smooth surface. Regular reflection takes place on smooth surface. So this is the smooth surface, highly polished smooth surface. Okay, smooth surface. So regular reflection. Okay, incident beam and reflected beam. Incident beam is parallel, then reflected beam also parallel to each other. So this type of reflection is called regular reflection. Coming to irregular reflection. Irregular reflection. So here I am considering, right? So irregular reflection. This is about irregular surface. Okay, right? Incident light rays are parallel, but reflected light rays are not parallel to each other. Incident light rays are parallel, but reflected light rays are not parallel to each other. So I am considering here. Now you can observe. These are the incident light rays. Incident light rays are parallel. but reflector light rays are not parallel to each other, so they will move in different directions. Reflector light rays move in different direction. Okay, here you can see reflector light rays are moving in different direction. Okay, so here also they will move in different direction. So this won't be there. These light rays are not parallel to each other. These light rays are not parallel to each other. Okay, so they will move in different directions. So incident light rays are parallel, but reflector light rays are not parallel to each other. Okay. Like this. Okay, so I hope it is very clear now. Incident light rays are parallel, but reflector light rays are not parallel to each other. So this type of reflection is called so irregular reflection. Irregular reflection takes place on a rough surface. Irregular reflection takes place on rough surface. Rough surface. Irregular reflection takes place on rough surface. Okay, irregular reflection is also known as diffused reflection. Irregular reflection is also known as diffused reflection, right? Yes. So now we'll go to the next topic. Coming to irregular reflection, magnetic effects of electric current I will discuss later. So now light reflection diffraction is going on. Electricity also I explained. So I will explain magnetic effects of electric current. Okay. So user ID. Okay, I will teach. So all topics I will teach. First we are going with the light reflection and diffraction. So I will explain the chapter. Then remaining. Now, so coming to the light reflection and diffraction. So we will discuss about object and image. So I am taking this is a plane mirror. This is a plane mirror. Okay. So here object. So light rays are coming from here. And here also after reflection those are moving away from it. Here also those are moving away from it. If you are extending these light rays, so here image will form. Okay. So real object and virtual image. Real object and virtual image. Real object and virtual image. Okay. So here you can see. So I am taking the plane mirror here. So here this light rays are coming from infinity. After reflection those are moving from here. Light rays are moving here. So here this is the real image. If you are extending those light rays also, this is a virtual object, real image and virtual object, real image and virtual object, real image and virtual object. Okay. Now we can conclude that by seeing these two, we can conclude that Object and image. Object is real, image is virtual. Object is virtual, image is real. So here you can see from this point light rays are coming. After reflection those are moving away from it. So if you are extending these light rays are meeting at one point here, virtual image. So here from this point light rays are coming. So light rays are coming from infinity. After reflection those light rays are meeting at one point. So this is the real image, real image. So if you are extending these incident light rays, extended incident light rays are meeting at one point, their virtual object is forming. Virtual object. This is a virtual object. I hope it is very clear. This is a virtual object. And coming to here, virtual image. So object is real, image is virtual. Object is real, image is virtual. Object is virtual, image is real. Object is real, image is virtual. Object is object. You are taking here. So this object is virtual, image is real. Object is virtual, image is real. Object is virtual, image is real. Clear? Okay. So once again check here. Object is real, image is virtual. Object is virtual, image is real. Very, very important. Very, very important. Make sure that you are learning this one. Learning this one. So very clear. Right. Next one. Next one we will discuss about one more. That is okay. Now, so now you can see here. Now you can see here. Right. So object is real, image is virtual. Now you are taking the plane mirror. So I am taking the plane mirror here, plane mirror. So object I am considering here, object, this object. One light ray I am taking like this. After reflection it passes. Normally if the light ray is passing along the normal line, what happens? If the light ray is passing along the normal line, so it retraces its original path. So it retraces its original path. If the light ray is passing along the normal line, so it retraces its original path. Yes or no? Yes or no? Same thing here also. If the light ray is passing along the normal line, so along the normal line, if the light ray is passing along the normal line, so it retraces its original path. So it moves in the same direction. It moves in the same direction. And one more light ray I am taking here. So it will be reflected back. And here one more light ray I am considering here. So it will be reflected back. So incident ray. And if you are extending the reflector light rays, so reflector light rays will meet at one point. Okay, reflector light rays will meet at one point. Their image is forming, that is virtual image. Okay, reflector light rays are meeting at one point, so their image will form, that is virtual image. Now you can see here. So here, if you are extending this incident light rays, okay, so here if you are taking here and here also, okay, here image form AB and A dash B dash, AB and A dash B dash, right? Yes. So by seeing this one we can conclude that object is real, image is virtual. If object is real, first point is object is real, image is virtual. Image is virtual, object is virtual, image is real. Coming to the second point, height of the object is equal to height of the image. Height of the object is equal to height of the image. Okay. I will take class on 9th syllabus physics. Definitely I will take Malik. So I'll take a 9th class syllabus. Okay, soon we'll start. right? So here I am taking object distance is equal to image distance. So the distance between object to mirror is called object distance. The distance between mirror to image. So here is the middle one is the mirror. The distance between object to mirror is called object distance. The distance between mirror to image is called image distance. So object distance is equal to image distance. Coming to the third one, height of the object is equal to height of the image. Height of the object is equal to height of the image. Height of the object is equal to height of the image. I hope it is very clear. Next one, fourth one. So magnification is plus 1. Magnification is plus 1. Magnification is plus 1. Understood or not? I hope it is very clear. Check once here. So object is real, image is virtual. Object is virtual, image is real. And object distance is equal to image distance. Object distance is equal to image distance. And also height of the object is equal to height of the image. Height of the object is equal to height of the image. And also magnification of the plane mirror is plus 1. Magnification of the plane mirror is plus 1. And coming to the fifth one, it also shows lateral inversion. What is the lateral inversion? Lateral inversion is nothing but the phenomena of converting of right side of the object appears to be left side of the image. Left side of the object appears to be right side of the image. Once again, so right side of the object appears to be left side of the image. Left side of the object appears to be right side of the image. So this mirror image is called lateral inversion. This mirror image is called lateral inversion. Once again, if the object is real, image is virtual. Object is virtual, image is real. So image is real, object is virtual, vice versa. And coming to the second point is object distance is equal to image distance. Object distance is equal to image distance. Coming to the third point is height of the object is equal to height of the image. Height of the object is equal to height of the image. And coming to the fourth one, magnification of the plane mirror is plus 1. Magnification of the plane mirror is plus 1. Magnification of the plane mirror is plus 1. Okay, and here lateral inversion, it also shows lateral inversion. So what is lateral inversion? Lateral inversion is nothing but, so the phenomena of converting of right side of the object appears to be left side of the image. Left side of the object appears to be right side of the image. This mirror image is called lateral inversion. This mirror image is called lateral inversion. I hope it is very clear to you all, right? So that is about object and image, and nature of the image formed by the plane mirror. Right? Next one, we will discuss one more, that is so next one is spherical mirrors. We'll discuss spherical mirrors. And actually we need to discuss the laws of refraction. Actually we need to do so many problems like related to light reflection and refraction. We need to work out. Definitely I will explain. And we'll see. Coming to spherical mirrors. Okay. So what is spherical mirror? Spherical mirror is nothing but the mirror which is in the form of curved shape. Okay. So the mirror which is in the form of curved shape is called spherical mirror. So I am considering here like this. Okay. So here I am taking the small portion. Right. So I am taking the small portion, that is called curvature. So curvature, right? Curvature I am taking. Right? Here, so depending on the reflection of light, there are two types of mirrors are there: concave mirror and convex mirror. So reflection takes place inward. So I am taking the concave mirror here. Reflection takes place inward is called concave mirror. Reflection takes place outward is called convex mirror. So here reflection is taking place inward. So after reflection, light rays are moving towards the principal axis. Light rays are moving towards the principal axis, coming to the convex mirror. Coming to the convex mirror. After reflection, light rays are moving away from the principal axis. After reflection, light rays are moving away from the principal axis. So concave mirror is also known as converging mirror, whereas convex mirror is also known as diverging mirror. Concave mirror is also known as converging mirror. Convex mirror is also known as diverging mirror, right? So concave mirror is also known as concave mirror or converging mirror. So whereas convex mirror, convex mirror is also known as convex mirror or diverging mirror, right? Diverging mirror. Okay, I hope it is very clear. So this is about the concave mirror. Concave mirror is also known as converging mirror, whereas convex mirror is also known as diverging mirror. Diverging mirror, right? So next one we will discuss about terms related to spherical mirror. Terms related to spherical mirror. Terms related to spherical mirror will discuss. Terms related to spherical mirror. So now I am taking like this. So concave mirror. So it's a part of the sphere. Concave mirror is a part of the sphere. So center of the imaginary sphere in which mirror is a part. Center of the imaginary sphere in which mirror is a part. So here reflection takes place inward. That's why it is concave mirror. So the midpoint of the mirror is called pole. So this is the midpoint. Midpoint of the mirror is called pole. The line joining of central curvature and pole is called principal axis. So first one is central curvature, second one is pole, third one is principal axis, principal axis, and coming to the fourth one is the distance between central curvature to pole is called radius of curvature. The distance between central curvature to pole is called radius of curvature. So radius of curvature. Coming to the fifth one, after reflection, all light rays will meet at one point on the principal axis. After reflection, all light rays will meet at one point on the principal axis is called focus. Coming to the sixth one, the distance between focus to pole is called focal length. The distance between focus to pole is called focal length. So this is called focal length. And coming to the seventh one, the width of the mirror is called aperture. Width of the mirror is called aperture. Width of the mirror is called aperture. Okay, so aperture. So once again, so discuss about it. So the center of the imaginary sphere in which mirror is a part is called center of curvature. The midpoint of the mirror is called pole. So the line joining of center of curvature and pole is called principal axis. And the distance between center of curvature to pole is called radius of curvature. After reflection, all light rays will meet at one point on the principal axis, that is called focus. And the distance between focus to pole is called focal length. The distance between focus to pole is called focal length, and the width of the mirror is called aperture. Width of the mirror is called aperture. I hope it is very clear. Now we will discuss about ray rules of concave mirror and convex mirror. Ray rules of concave mirror and convex mirror. So ray rules of concave mirror will discuss ray rules. Here you can see ray rules of concave mirror and convex mirror. Concave mirror, concave mirror, concave mirror, and convex mirror, convex mirror. So concave mirror, right? So first one I am taking here. So pole, focus, center of curvature. So I am taking the concave mirror. After reflection, light rays are moving through focus and coming to the second. So pole, focus, center of curvature, light rays passing through focus. After reflection, moves towards infinity. Coming to third one. So this is the pole, focus, center of curvature, light rays passing through center of curvature. So it retraces its original path. Coming to the fourth one. So light rays passing through. So pole, focus, center of curvature, light rays incidenting at the pole. It reflect back. So now you can observe here. Okay. Now you can observe. First point is light rays coming from infinity after reflection passes through focus. Light rays passing through focus after reflection moves towards infinity. Light rays passing through central curvature retraces its original path. Light rays pass incidenting at the pole, it reflect back. And coming to the next one, convex mirror. First one is, so here I am taking convex mirror. So this is the pole, focus, center of curvature, light rays passing after reflection, it passes through focus. And coming to the second one, so pole, focus, center of curvature, light rays passing through focus after reflection moves towards infinity. So if it is passing, it moves like this. And coming to the third one, so pole, focus, center of curvature, light rays passing through center of curvature, it retraces original path. And coming to the fourth one, light rays incidenting at the pole. So pole, focus, center of curvature, light rays incidenting at the pole, it reflect back. Light rays incidenting at the pole. So it reflect back. So 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Right? I hope it is very clear. Okay, done. So now we will discuss about image formations of concave mirror and next convex mirror also. Right? So let's do. So image formation image formation by concave mirror. So first one I am taking here. So pole, focus, center of curvature, pole, focus and center of curvature. Light rays, object is at infinity. How many light rays are required? Minimum 2 light rays are required. Yes or no? How many light rays are required to form the image of the object? So we'll discuss now. So first here, so two cases. Object is at, so I'm taking here pole, focus, center of curvature. Object is at infinity. So object is at infinity. So first one is object is at infinity. So I'm taking like this. Light rays are coming from infinity. After reflection, those are meeting at one point here. Okay, object is at infinity. Image is forming at focus. Object is at infinity. Image is forming at focus. Nature of the image is real and inverted, and size of the image is highly diminished. Image size is, so very small image is formed at focus. Image size is highly diminished. Right? Coming to the next one. So object is placed beyond center of curvature. So this is the pole, focus, center of curvature. Object is placed beyond center of curvature. So object is placed beyond center of curvature here like this. So one light ray I am taking like this. After reflection passes through focus. Another light ray passing through center of curvature. Then it will be reflected back. So image will form between C and F. Image will form between C and F here. Object is placed beyond center of curvature, beyond C. Image will form between C and F. Nature of the image is real and inverted. And size of the image is diminished. Because image is formed between C and F. So nature of the image is diminished. Okay. Next one. So this is second one. Coming to the third one. Object is placed. So this is the pole, focus, center of curvature. Object is placed in center of curvature. Object is placed at center of curvature. So I am placing the object is at center of curvature. Where image will form? Image also will form at center of curvature itself. Okay. So now image will form at C itself. Image will form at C. One light ray I am taking like this. So another light ray passes through focus. Okay, object is at C, image also will at form at C. Nature of the image is real and inverted. Size of the image is same size. Same size. So coming to the fourth one. Here you can see. Object is placed between C and F. Object is placed between C and F. One light I am taking like this. After reflection passes through focus, another light ray is incidenting at the pole. So it reflects back here. Image will form here. Object is placed between C and F. So image will form beyond center of curvature. Beyond C. Nature of the image is real and inverted. Size of the image is enlarged. I hope it is very clear. Right? Okay, next one. So fifth one and sixth one, fifth case and sixth case we'll discuss. Okay, so now you can see here. Now you can see. So now fifth case and sixth case. So we'll discuss fifth case and sixth case. Fifth case and sixth case. So object is placed. So pole, focus, center of curvature. Object is placed at F. Object is placed at F. So one light I am taking like this. So after reflection passes through focus, another light ray incidenting at the pole, it reflects. So object is at F, image will form at infinity, nature of the image is real and inverted, size of the image is highly enlarged. Right? Next one. So coming to the sixth one, last one. So pole, focus and center of curvature. Object is placed between F and P. Object is placed between F and P. One light I am taking like this. After reflection passes through focus, another light ray inciding at the pole, it reflects back. So if you are extending these light rays, those light rays will meet behind the mirror. Okay, so here. So object is placed between F and P. Image will form behind the mirror. Image will form behind the mirror. Behind the mirror. Nature of the image is virtual, erect and enlarge. Virtual, erect and enlarge. I hope it is very clear. So listen carefully. This case is very, very important. They will ask for 3 marks. This question is very, very important. So many times in board exam, this question asked. Okay, so expected question, even midterm, slip test, unit test, so quarterly, half yearly. Okay, so free panel 1, free panel 2, so any exam. So this question is expected question, very, very important. Try to prepare this one, try to practice this question. Object is placed between F and P. Image will form behind the mirror. Nature of the image is virtual, erect and enlarge. Right? Yes. Next, coming to the virtual image. Virtual, like a convex mirror. Convex mirror. So it always forms virtual, erect and diminished image. Convex mirror, we'll discuss about convex mirror. Convex mirror. Only 2 image formations are there, convex mirror. Convex mirror. So this is about pole, focus, center of curvature, pole, focus and center of curvature. So object is placed at infinity. Object is placed at infinity. Object placed at infinity. 2 light rays. I am taking 1 light ray and another light ray. After reflection, so these light rays will move away from it. If you are extending these light rays, the image will form at focus. So image will form at focus. Nature of the image is virtual, erect and highly diminished. So this is the first one. Coming to the second one, object is placed. So this is the pole, focus, center of curvature. Object is placed here. How many light rays are required? Minimum 2 light rays are required, right? So that's why I am taking 1 light ray here, another light ray like this, and here. So if you are extending this one, the image will form between P and F. The image will form between P and F. Object is placed between infinity and pole. Nature of the image is virtual and erect, diminished. Virtual, erect and image is formed between image is formed between P and F. Image is formed between P and F. Nature of the image is real, virtual and direct. Nature of the image is virtual and direct. So diminished. Okay. So that's enough. This is about convex mirror image formations. Convex mirror image formations. Once again, you can observe here. Object is placed at infinity. Image will form at focus. Nature of the image is virtual, erect, and highly diminished. In this case, object is placed between P and infinity. Image will form between P and F. Nature of the image is virtual, erect, and highly diminished image. Image is diminished image. Okay, so that's enough. Next one. Next one, we will go to the next one, that is coming to the sign conventions. So now we will discuss about sign conventions. Sign conventions. Sign conventions. Sign conventions. Sign conventions. So here, pole, focus, center of curvature. Pole, focus, and center of curvature. Now you can see here. Now you can observe. All measurements will be taken from the pole. All measurements will be taken from the pole. In the direction of incident rays, all are positive. Opposite incident rays, all are negative. Above the principal axis positive. Below the principal axis negative. So all distances measured from the pole. All distances are measured from the pole. In the direction of incident rays, all are positive. Opposite incident rays, all are negative. Above the principal axis positive. Below the principal axis negative. What are those distances? So all measurements we have to take from the pole. So in the direction of incident rays, object distance, image distance, focal length, all are positive. Opposite to incident rays, object distance, image distance, focal length, all are negative. Above the principal axis, height of the image and height of the object is positive. Below the principal axis, height of the image and height of the object negative. How can you say like that? So we can take. Okay, so I'm considering here negative. So all here I'm taking this origin, positive x-axis, positive y-axis, negative x-axis and negative y-axis. So same, however you are considering same like coordinate axis. All measurements will be taken from the pole in the direction of incident rays, all are positive. Opposite incident rays, all are negative. All distance are measured in the direction of incident rays positive. All distance are measured in the direction of opposite incident rays negative. All distances measured perpendicular to the principal axis above the principal axis positive and below the principal axis negative. As like a coordinate axis. Okay, so thank you so much for joining and attending, listening the class. So we'll discuss a refraction phenomena, about refraction we'll discuss, about refraction topic we'll discuss. So until now, reflection. So I will sing one song for you. Okay, ready? New Cartesian, sign convention, new Cartesian, sign convention. Distance are measured from the pole. Distance are positive along the incident rays. Distance are negative opposite to incident rays, distance are positive. Above the principal axis, distance are negative. Below the principal axis, new Cartesian, sign convention, new Cartesian, sign convention, all distance are measured from the pole, distance are positive. Along the incident rays, distance are negative. Opposite to incident rays, distance are positive. Above the principal axis, distance are negative. Below the principal axis, new Cartesian, sign convention, new Cartesian, sign convention. So thank you so much. This is our Siva sir from Student D Brand. So if you like the content, if you like my explanation, if you like the channel, do like, share and subscribe to Student D Brand. And you can inform your friends. You can ask your friends to join to the class. This is our Siva sir signing up. Thank you.